Hello, I'm Diederik VInk,
And I'm Garcia.
and we are first year Electronics and Information Engineering students at Imperial College London.
Also known as EIE.
And what we had to, as our first year project, what we had to do was create a system that does real-time image processing using an FPGA as we have right here. And what we've done is we've developed a virtual piano.
We have both done music before university, so I myself play the piano and he plays the viola. So we wanted to make something that was at the same time entertaining and technically challenging. So we used a D0 Altera board, which we programmed using Quartus and Catapult C. To make the piano, we created these printed pianos. They don't have black keys because that was quite a challenge. So we also used an analog to digital converter board from the second year digital electronics course, which is connected to a loudspeaker that produces the sound for the piano.
And we were also given the D5 and 5 megapixel camera attachment for the FPGA to take in any video feed.
So now we'll go over some of the main features of the camera, and it's working. As you can see,
Alright, this is us playing the piano. Up here, the hex displays will show what key is being played, and the LEDs will show the key number. Show one of the other features of the piano, such as the octave changing feature. So I'll play B. This is the same note played an octave down. And this is the same note played an octave up. You can also do sharp notes. So this is a sharp note. You can also change the octave from major to minor. So this is a minor octave. And this is that same octave as a major. The last feature is a happy birthday playing automatically.
So how we managed to do this, we had to detect the piano. You're currently seeing the video feed of the camera, but by changing a button you can access the edge detection feed. This detects the edges between the color white and the color black, which allows us to, in a way, detect the piano. We do this two ways. You can either, in the setup mode, click on the corners of the screen of the piano. So like you can click in any order. Once you've clicked in all the corners, and the corners are saved, it decides which corner to which. As you see, they have unique colors that each corner is associated to one color. And from those corners, by dividing the coordinates the corners are, it assigns certain coordinates to be a key. So now when my finger enters one of these areas, it can count the edges inside the area to see if the actual key is being played. But we also have automatic detection mode. So by changing well, here you can also see that the hex display shows if you are in manual mode with a hand or in auto mode. Once I change these, I change into automatic mode. So in automatic mode, as you can see, there's two magenta and two blue lines that define where the key is going to, where the keyboard is going to be searched for. This is just in case there's some random noise, for example, in the border. If you can also see, the pianos have a bit of extra borders so that it detects them. The algorithm we used is basically it searches for the highest edge and for the lowest edge, for the rightmost edge and for the leftmost edge, and then saves those on edge corners. So if I actually change the piano, the automatic detection search for the corners and redoes all the keys, so that now, once I save the setup, I can change it to video feed, and I can play the piano again. Sound on?